Hey, I'm Wiebke. I met most of you, or I met all of you this morning already. There are a lot of things that you don't know when you get co-opted to sign up to do an R talk 4 months before it's actually due. And so Theone approached me and said, will you do an R talk? And in November last year, I thought, yeah, sure, I'll do that, no problem. And I wasn't at satRday last year, so I started thinking, I went through the process of signing up and thought, 20 minutes standard talk, great. And then then 2 weeks before the talk, you arrive and you see, oh no, all the standard talks seem to be 5 minutes. Why on earth did I sign up for 20 minutes? Anyways, and now I've got the afternoon shift. So you guys are going to have to do me a favor and all quickly get up so that we can do some brain jiggling and get some juices flowing again, because I'm getting drowsy. Okay, so let's do it in 30 seconds. The first exercise is you're going to take your right elbow to your left knee and then the opposite. So you're just going to do 10 of these. Yes, you'll see it's amazing. Okay? And it's going to get more complicated after this. Okay, cool, sweet. So your second level is up one notch. We're going to take the right hand at double speed and the left hand at single speed. And if you feel you've mastered it, then you can swap around and do the other direction also. Apparently, if you do this every morning, it makes you smarter in the long run. Okay, this is maybe as funny as my talk is going to get, so embrace the moment while it lasts. So the other thing I've observed in terms of, other than the keynotes, which of course were in a lot of depth, but I felt a lot of the 5-minute presentations were so great and so full of content that maybe the only difference between 5 and 20 minutes is the speed at which you talk. And I'm normally a very fast speaker, which means this will be quite a challenge to me because I'll try to slow down a lot. So my talk is about CKAN R. I'll give a little bit of introduction of how I arrived at CKAN first. But before that, let me give you an overview of the talk. I'll introduce CKAN and open data portals in general, then a quick demonstration of what is possible, bit of code in terms of getting started with CKAN R, very slim typical workflows. I think in terms of what a lot of the talks have presented today, the workflows tend to ultimately be relatively similar. And then a link to some resources to get you started. So I've been employed at the Energy Research Center at UCT for the past 2 years to build an open energy data portal. And my mandate when I was employed was very much one of, we have a data problem, please help us solve it. And I considered myself quite fortunate at the time when I started, because so many open data resources started being quite readily available that weren't available before, and CKAN being one of them. And to me now, 2 years later, there's also an element where you start scratching your head and you look back and you look back at the depth at which you went into acquainting yourself with a particular technology. And when you emerge out of it, you see that the world has moved on a little bit also in some ways. So what I'd be really curious about, if none of you are going to have questions for me at the end, I'm going to have questions for you, because I'm quite curious to find out, in terms of research groups and in terms of how you work, how do you manage your data collectively? So you can ponder that if you don't have questions about my talk. So CKAN stands for the Comprehensive Knowledge Archive Network. It's the world's leading open source data portal platform. And so the reason why I settled on CKAN was, well, for one is because initially my mandate was just to build a database, and at that point I'd never built a database, and I didn't realize either how much heavy lifting is involved to really take something from data, like from storing data to actually serving it on the web in a really nice and user-friendly way. And CKAN is really great because it does all of that. It's free, it's well documented, it's got a large user community, it's customizable to individual user needs, it's got individual login profiles, it's an online place for any type of data sets. What is really nice is it can take PDF, Excel files on the one hand, but then also if you save your data as very nice CSV files, where very nice basically means very limited because it can only have a single row header and a single column, and basically needs to be a completely flat table. Then you can also query the data directly with an API, which is pretty cool. And also, it's a data package that's hosted by our OpenSci. So that's pretty cool. Wait, we are OpenSci, yeah. And yeah, so ultimately what got me excited about it also is that you can retrieve it with an API. There are a couple of data portals in South Africa that have been built out with CKAN. And I think, again, the more open data portals come online, the more useful it also, or the more powerful it becomes, mastering tools like, wait, let me backtrack a little bit. One of the tricky parts I faced in my research group is that people have been using Excel for years, and they're very comfortable with Excel. And so encouraging people to migrate away from Excel to coding languages can be quite a daunting task. And what I've tried to dangle in front as a carrot is saying, if you learn R, then you can very easily create these really great workflows to access data in open repositories. And so I think as more and more repositories come online, I think that it will hopefully over time become a good way of coaxing people that are slow to get on the coding bandwagon to engage with code. So the SA Online Budget Data Portal is one that has been developed pretty recently, as in released in February. And it's a CKAN data portal that hosts South African municipal budget data. The Energy Research Data Portal is the one that I've been building out. Then Open Africa is a very large open data portal that contains a wide variety of different data sets. What makes data portals quite tricky is that, or I think maybe where we've struggled a lot as a research group, is in terms of identifying how open or how closed should it be, which data sets are proprietary, which data sets should be in the public, which data sets, like what kind of levels of user access do we want to have. And I think it's really been this navigating. We've positioned ourselves in this, or we positioned in a space where there's a lot of data related to energy research. Some of it is PDF files that have, is data tables that have been taken out of PDF files that only exist in PDF files that get used again and again and again. And there was this request or this need to say, how do we actually put this data out in a space where everybody can use it, that we don't have 100 people reusing, reclipping the same PDF files. So this is a sample view of what an open energy research data portal, or what a CKAN data portal looks like. This is our energy research one. It's got a really cool search area. It's got space for displaying reports. And yeah, quite nice. Once you actually get to a data set, you can choose to preview it. And when you come to preview, you can say go to resource, which downloads it for you. Or if you are an R master, you can use CKAN R. This is an example of what we've done with a data set that has been hosted on CKAN in terms of putting it into a Shiny app and making it fun and available. Yeah, so it's a South African greenhouse gas inventory, which again has been, in terms of where it's sat, it's a national statistics type document that's published as a PDF file. We've taken all the tables in the PDF file out of it. We've put it into CSV files. We're hosting this, or we've put the CSV files online, and because they're online and accessible, CKAN R allows us to query them directly and provide a Shiny app that anybody can browse the data really simply, really easily, and play with graphs. So this tool, we've called it the GHGVIS, so greenhouse gas visualization. I'm going to go into this code step by step, but that's basically what is required in order to fetch the resources and make it available for Shiny. So it's detailed in the slides that come. So the first part is you need to set up CKAN R. Very easy. Let me actually check, is there? Okay. So yeah, you load CKAN R as a package, then you have to set up CKAN R. Setup usually happens, or always happens, with the URL of the portal you're accessing. Some data sets in the portal will be private, others are public. If you don't have your own key, you can only access the public data sets. And then if you say CKAN info, you can see again details about the actual data portal you're accessing. The types of, the way the data in CKAN is structured is that you've got groups, you've got users, organizations, packages, and resources. So from a syntax perspective, that's sometimes a bit tricky because a package is a collection of data resources where an individual CSV file would be a data resource, and then a collection of CSV files would be a package. So for example, if you monitor a specific data set for several years and you want to have data from 1994 to 2004, for example, you could have that whole 10 years would be your data package, and then the individual files for each year would be a data resource. So in order to search the packages, you can search them by query term. So you say, for example, package search where your query is carbon, and that then returns a list of all the packages that have got carbon somewhere in the environment. You can do a filtered query where you'd search for only packages that have mini grids results appearing in the same space, which then narrows down the search a lot. Or you could even say is you only want data sets where climate change appears in the title. In order to discover the results, you then use. Sorry, I just realized I've got an old slide set here that I didn't update. In order to query the results, you would go into the package. You can check which resources are associated with that package, and then find all the results that relate to that resource and get it directly into R. So essentially, an overview is the workflow is quite simple. You start by creating a new package on a CKAN instance. In some cases, that will require you to have an API key. In other cases, usually you can just go and upload it with a GUI. Then you upload your resources and data sets to the package. You go and create a new R project that can include Jupyter Notebook, Shiny, or something similar. And ideally, commit your project to Git for version control. Once that's done, you then use the CKAN R functions that I've just shown to retrieve data from your CKAN instance. You can create funky visualizations, you can share it with colleagues and friends, you can update it whenever you want. And the real pleasure lies in being able to share both data and your code as opposed to only the one or the other. This is how you spot a CKAN data portal. This is the CKAN logo, and it usually always says welcome in a very friendly way. There are these gray blocks, which are dead giveaway that you're on a CKAN data portal. And then typically, the data portals have got CKAN API or powered by CKAN written at the bottom of the page. Here's some resources to use for links. There's CKAN R on ROpenSci. Great docs for CKAN, and then I've put the starter code I've put in my GitHub repository if anybody wants to access it. And something that, unfortunately this version of the presentation doesn't yet have, but CKAN is just one of several types of open data portals that exist. It's used a lot in the open government data space. So internationally, a lot of cities, a lot of countries use it as a data repository. In the academic space, UCT has very recently launched their own open data repository using a software called Figshare. And Figshare, same as CKAN, has got its own R package. And so in the end, whether you learn to use CKAN R or Figshare R, it's essentially a couple of functions that you need to master, and it's a really great way of giving you access to a whole assortment of data. So I highly recommend learning it and using it and spreading it in your research groups. That's it. And if any of you are ladies or want to be ladies, you can join our ladies groups, which meets once a month, either on a Tuesday or a Thursday. And all the dates for 2018 have already been set up. You can find them on Meetup. Yeah, meetup.com. Cool, that was me.
Thank you.
Despite best efforts, I still speak fast.
Okay, any questions? So you mentioned that it was sort of, when you started this, was the first time you built a database, and you mentioned that there are packages that consist of files. How are you storing the information?
Yeah.
Is it a database, like as in SQL, or is it?
So the beauty of CKAN is it's got a Postgres database at the back end, and then so basically it provides a complete package of a Postgres database together with an Apache web server together with Nginx, and then together with CSS templates to do the styling. When I started, there was a Docker image that existed but wasn't maintained, and I'm pretty sure, I haven't gone back to check it out now, but I'm pretty sure there'd be a Docker image again. So I think it's potentially, I see it having potential where you've got a group, let's say, of 10 or 15 researchers where too much data sits in people's email inboxes, and again, like if the Docker image doesn't exist, it is a bit of an effort to learn to set it up, but it's still easy enough if a group is motivated. And it's a really great way of just consolidating where you store your data resources. Yeah.
A lot aimed at collaboration, I guess.
Yeah, exactly, aimed at collaboration. Yeah.
More questions?
Hi, two questions. One, does it also handle Excel files? And does it come with versioning of the documents? So can someone check out the file, so lock it, no one else, that it's being modified, so you don't have conflicts with multiple people editing the same file at the same time, and then update a new version?
Yeah. So it can handle Excel files. It can also handle shape files, PDF files, all of that. The problem with Excel, the thing with Excel, it treats an Excel file the same way that it would treat a PDF file, which is just as a file. Whereas a flat CSV file that only contains one data table is essentially treated as a database table. So you can't access the data in an Excel file directly. You'd have to download it and then use it. On the version control side, it's unfortunately not that great, so there isn't any inbuilt version control. We've tried a bit using, so the context in which we've been using it, for which we've built it, is energy modeling, where typically you'd have different iterations of models that you run, and again, typically those models, like the model gets set up with the parameters that it needs, it's run, spits out results for a specific project, and then parameters are changed, and that model is forever lost. And from that perspective, kind of from a workflow perspective, it requires quite a lot of rethinking how to do it. And ultimately, like the way we've envisioned it is like GitHub is still the place for version control. But what you could do here is, so here it's more once you've done a project, you'd save all the files that were required to run that project together with the version of the code that you used. So there is it's not a slick process. So it's more like it's almost of a, in terms of like speed of development, it's like it's like the slower, it's for a slower pace of progress. Yeah.
Okay. Any more questions? Thank you.
Can I? So I'm just out of curiosity. Is there anybody here who feels they've got managing data in their research group nailed? And if you have, could you share with me how you do it? No. Okay. Bummer. I thought I'd get lucky.
Okay. Thank you.